record. I'm going to start recording now. But it didn't say that. Hold on, guys. My Zoom is weird. All right, it says it's recording, but I don't see the normal thing. All right, oh, there it is. Okay, so just to recap, we're going to take our safety quiz. You can start on your lab as soon as you finish your safety quiz, kiddos that are in class. Guys online, I'm going to talk to you in just a second about how your safety quiz is working and how we're going to work the lab and things today. Okay, so give me just a second. And then I'll come around and collect your safety test. Yes, ma'am?
Are we still having that fire drill?
No, that's good. Ooh, there's something else I wanted to talk to you about too. So good. Fire drill has been pushed back to next Friday. So next Friday we're going to have a fire drill at 11:15. So a good little bit into class. We are doing another lab next Friday. So that's super fun. But I don't know why they all got pushed back. So that's excellent. Also, I've already posted an opportunity for extra credit, I believe, for you guys. I did also include a note for someone to remind me, but it's okay, because Addie inadvertently got me to talk about it. So here, yes, the Bio Blitz. How do I make this bigger? I don't know how to make this bigger. All right, so this is just under updates. It's some information. If you're a Science NHS member, it's also available for Science Hours. So there is this thing called a Bio Blitz. It's basically you're just going to take this app called iNaturalist, which is really, really cool. And you can download it to your phone. It's free, and you're just going to go out in your backyard or a park near your house, wherever, and you like scan flowers and things, and it tells you what it is. But it also starts to create a catalog of what's available in, like biodiversity in that area. So check that out. There's more information here. You do need to register. Well, they would like for you to register. I don't think that information comes to me. So how should we, you should show me your iNaturalist. Maybe I'll put an assignment so you can submit like a little screenshot or something of your participation. Okay? Awesome. Any other questions? Guys online have any questions? No, I see heads shaking. All right. All right. Then let's go ahead and get started. Take your quiz. All right, online kiddos, your quiz is on Schoology. It has been assigned to you, so if you just go into your upcoming assignments, you should see it in that right-hand column, just like it is on mine. Okay, you just click on it. You only get one chance, so please be careful and you don't click ahead or click too fast. Okay, and then once you're finished with that, we're just doing the lab today. So jump in the chat or speak up if you have a question or a problem with the lab. Okay? All right, go ahead and get started. Stop sharing. I'm going to mute that first. I'm going to stop sharing. Good there. Change the direction.
Yeah, you'll use the same penny over and over again, and just dry it off, and if you need more paper towels, just let me know, I'll give you more paper towels. They're better than brown ones, but they're not, and that's just throw back.
Hey Cameron, what's up?
I'm just gonna get off now.
Yeah, absolutely, absolutely. So you guys that are done, if you want to read through the chat, you are welcome to work on this lab offline. I am going to stay online, for the class period. So if you want to hop back on, if you want to do this at another time, that's fine. You do not need to use distilled water, tap water. That's what we're using in class, or water bottle is fine. And any type of liquid soap is fine. We're using hand soap in the classroom. Okay.
Thank you.
Yep, no problem, guys. And you can Schoology message too, okay? Thank you.
Let's just grab these.
Oh, no, let me give you a white paper towel. Yep.
Are we doing anything else during class? Like, do we need to come back on, or is this all we're doing?
I mean, this is all we're doing. It's really just kind of getting back and used to doing labs and activities in a non-stressful way, doing some practice with stats. And then the big thing about this lab is also how to submit things appropriately to Schoology. So, if you finish within the class period time and have trouble with that aspect of using CAM Scanner or whatever PDF program you want to use, I can help you troubleshoot. Okay?
Okay.
And if you don't want to choose to do it now, which is fine, since you guys are online, you can come to office hours or message me if you're having difficulty uploading it. You have until Friday, though, to upload it.
And then for the lab report,
Uh-huh.
is all like the information for that on Schoology?
Ma'am, within lab directions. So it's mainly just collecting that data, doing your graph and your calculations, and you have a little bit of conclusion questions, and then taking pictures of your notebook. There's nothing to type up, okay? So you're just, what you write in your notebook, you're just taking pictures of those, turning those into a PDF, and uploading that to the assignment.
Okay, thank you.
Yeah, no problem, Jack.
Bye.
Okay, bye. Have a great weekend.
You too.
All right. All right, so they all logged off, so you guys get my undivided attention. How fun is that? All right, I am going to stay on, but I'm going to turn this microphone off. All right, you guys are more than welcome to have conversations and things. I mean, you don't have to be quiet. And so if you heard me telling them, if you were listening, eavesdropping a little, which is fun, because it's the same information. This lab is not about serious biology, right? This is cohesion and water property. It's super cool. I love this lab. It's so, like, just fascinating. But it's also about practicing with stats, integrating our stats, okay? So you guys had some stats, it's been a while, right? You know, there you go. And then also really learning how to submit our labs appropriately, okay? So I fully anticipate having some downtime at the end of class. And it's rare, so we're going to enjoy it. Absolutely, yes. And when you're ready for soap, let me know. I can't have everybody touching the soap, which is weird. So I'm just going to come by and give you a little squirty squirt.
Got 33.
There you go. So you take your finger and kind of share it on there. And if you need more for your other trial, absolutely. Here we go.
You're gonna need newer.
Okay. Would you like to do paper towels for a year? Oh, absolutely. Yeah, for your book, awesome. Ms. Book and I were talking about how we're going to do that. So see. Yes, ma'am. So that's something you're going to want to discuss in your conclusion.
So you guys, everyone be picture ready.
You know,
It's like, it's a
yes.
and I can show you.
Yes, ma'am.
We'll get steps in. I think,
Oh, yeah.
yeah, what is it? I told Glenn I might have to up my step goal. I think 12,000 is not gonna be enough.
Oh, yeah.
I'm gonna have to go up to like 15. I used to reach 10,000. Okay. Oh, yeah, you need that.
Oh, my God. I don't know why, when I do it, they're probably just like a little, but.
It's okay, your water likes to run free. There you go. You need
So
to
like, what am I gonna do? Am I gonna like scoop it up through
No,
there?
you're just gonna take your finger and then kind of smear it on the
Oh,
wood.
okay.
Yeah. Yeah, no problem. What are you here for? Sorry.
I need to be sure your power ends up.
I'm gonna come to your desk then. Yeah. Sure.
Thanks, guys.
So you're gonna take your finger and smear it on, and if you decide you need more soap, then let me know.
Oh.
How are you guys finding everything so far? Is the workload okay? And the ACA year is okay so far? So far, so good, right? It's early, I know. So yeah, I'll pull them up and see. They're just little surveys, so really quick and easy. One of them is I'm not collecting the safety contracts this year. I am. And that might have been a time where you were out with Ms. Fuller,
I think that's
Baxter. Okay, so here we are in our little course. Right here in our course information, Baxter, this purple folder, right up here.
Oh, okay.
Okay, underneath the syllabus, okay, you have your student survey, so that's for you. This is a parent survey. If you could have one of your parents do that, that'd be really great. And then this is your Google form so that you're accepting your safety contract, okay? Do make sure you have to type your parent's name in, but when you do that, you're typing that they're aware of the safety, so have a conversation, okay? Because if you do something unsafe, I'm gonna say, I have this safety contract.
Yeah.
Yeah, you're gonna wanna put these soap on for each of your child, which is fine. If you need more soap, let me know. That's fine.
I just got 15 new soap.
Yeah, no, I thought that.
What'd you get for those?
I thought it was one.
I Getting down to my drill.
I didn't have a book there.
Are you ready for soap too? Okay.
Yeah, I'm just gonna.
There you go.
So the ones with just water I got in the city,
Me
and
too.
then for the other ones I got in the.
So far that looks like pretty, significant, right? But that's why we're gonna do our statistical test.
Soap on the community.
So you just stick your finger in it and then smear it. Yep. And then you didn't put it away, and that's nice.
Yeah.
Absolutely.
Yeah, I got soap, I got.
That's right, soap will get everywhere. Exactly.
Do you want the penny back?
I do need the penny back, I know that's weird, and I have to soak it in bleach overnight.
It's so penny and.
The one
Yeah.
Penny covered it.
Not in pure bleach, but yeah. All right, so when you're done, dump your water out in one of the things, preferably the one that's kind of behind Addie and away from everybody. All your plastic and your trash can go in the trash, and I'm gonna get a little glass container out and put it next to that safe for you to put your penny in. Try not to touch the glass bowl, okay?
Try not to touch anything this year, right? All right, so here's our glass ball with Penny, just kind of drop it in. Try not to touch. That is going to be thrown away too. I know lots of ways. Penny's going to go in the glass jar. Of course. You're welcome.
Can I use the restroom?
Yes, ma'am. Yes, ma'am, and shirts.
What do you want us to do with these?
That's all going to be thrown away. Very wasteful this year.
That,
Yeah, like the lunch, how they serve each lunch and stuff.
I know, it's so, water, just dump it in the sink.
they've always been bad about waste.
Yeah, that is.
Yeah, but now they're handing it to you in a plastic bag.
They make you a bag with every possible sauce you could want in it. Like, I'm not using Texas pink mayo, mustard, and ketchup.
Yeah. Pull out my room. Alright, so today is mine.
I also think that it's all everything that's just keep it, no one's throwing. Roll the funny one. Yeah.
Yeah, honey mustard is best for
That's the only good one. We put it on everything.
Okay. All of this. All right, I did need to talk to the other kiddos about this too. I'm gonna send them a message about it, but I'm gonna talk to you guys about it while I remember. So we ordered online software codes, trash, I know. So, everything but the penny. And then you're dumping water in the sink, yeah. For that, so we got online lab access, okay? But I know a lot of you guys want face-to-face and hands-on experience, right? So there's a few different ways that we can do labs. What I was thinking is that we would be in lab groups of 3, with 2 people in class, and maybe pair up with 1 person that's not in class. Yes, ma'am. And then the 2 people that are in class would maybe rotate through the labs each week, okay? So that's one way that I was originally thinking before we got this access code. We can still keep that method, but you will always have the option to do the online, okay? So like say, if Addie and I were partners and it was her week to do the lab and I didn't want to just sit and watch, I could do the online lab, okay? For some labs, it might work out where I can get everybody in the class like this one to do their own. You have your own hands-on experience. But for a lot of the labs, I can't because they're kids, okay? So think of that. If you can think of another way to make it work, let me know, okay? I am open to ways. And if you are in groups, I will let you use your phones and FaceTime and, so you can see, you can be part of the lab. It's not like you're just watching from afar, or those people that are our counterparts that are online, they can participate in labs too, okay? All right, so once you're finished with your stuff, you can work on your statistics, you can work on your graph, and then your conclusion questions. The idea is to get it all done in class today, then we don't have to worry about it.
How do you do a t-shirt?
Okay, how do you do t-test?
I don't think we know yet.
Oh. Yeah, so you gotta come up with your hoe and your haw. So what's your hoe and what's your haw?
What?
What is a hoe and what is a haw? A null hypothesis, which one is the null hypothesis? Yeah, so your HO is your null hypothesis, okay? And then, so what does that make your HA, your HA? What is that? What is a null hypothesis? Let's start with that. It's okay if we don't remember. I won't tell Miss Shay. She did. She got a really good job opportunity. Lucky duck.
Something that's like equal to 0.
Yes, so yes.
And it's like greater than or less than two other things.
Yes, and ready for some super secret. I'm trying to figure out how I'm gonna share this because I'm recording it. And I know they're gonna have the same question that you guys have. So how do I want to do my screen? Yeah, she's at Virtual Virginia. She's supervisor, advisor.
Oh, yeah, that's great. Okay. I'm going to try and put this on my cart because I don't need to project. And I'm going to wheel around. I know. All right. Then I'm going to adjust. I think. And then I'm going to hope I'm writing. And I'm sorry, you guys are right in the way. All right, but I'm going to write high, so it's going to be okay. I think I'm going to write high. Where is this? It's all right. Yeah, I like Miss Shay. I can be called Miss Shay. So the penny goes in the glass jar, and then your water gets dumped out, and the rest of the stuff goes in the sink. All right. So your hoe, this was just for me to see where I'm typing here. Your hoe is your null hypothesis. What, baby? What are we talking about? This goes in your t-test, and you can just listen if you want, okay? Okay, that sounds good too. All right, so your null hypothesis. Ready for some really good news about null hypothesis? It is 100% always the same in biology class, okay? Your null hypothesis is always the same, and it doesn't matter what statistical test you're using. If it has a null hypothesis, it's always the same. And the null hypothesis is there is no statistical difference between variables. Yes, okay, good. So there's no statistical difference between variables. Now, when you're writing it for a lab, we do want to be specific. So what are our variables here? What are we looking at? The penny and the water droplet. So what would we say? And if you just write this, that's fine. You can then clarify for this lab, it would be, there is no statistical difference between, even more specific though, what was different between your penny? Yeah, and so we're going to get a little bit more, a little less words and say there's no statistical difference between soap and no soap on a penny, okay? So that's your null hypothesis. Okay, I'm going to move this out of the way so you guys can see. Excuse me. No. All right, so your, where's the lab? Two. Lab one go. Oh, because this is 18. I don't want 18. All right, so now we need to talk about the other one. I'm going to move my little thing back. Right there, looks good. Okay, so the other one is your HA, and those are subscripts, okay? This is not really an O for the HO. It's really a 0. It's for the hypothesis not, okay? It's there is no difference. Anything that looks like a difference, it's random chance, okay? But your HA is your alternative hypothesis or your experimental hypothesis, okay? And so in this case, it's usually the opposite. But then also, which one do you think would be better, okay? So what do you think we could make, or how would we word our experimental hypothesis in this case? There is, so we're going to start with that. First of all, there is a difference. There is a statistical difference. We want to be more specific. And then we're going to pick our direction. There's a statistical difference in which one is higher. In this case, which one would hold more drops? Yeah, the water. Okay. All right. So there is a statistical difference, and water alone, because they both had water, right? So we need to be more specific. So water alone will hold more drops. Yeah, something like that. And I got it on the screen. Okay. All right, so that's step one. We got to figure out what our ho and our ha are, okay? All right, so then the next thing we're going to do is we need to look at our p-value. Also, in biology, your p-value is always the same. Life with statistics is so much easier in biology class. All right, so your p-value, first of all, does anybody remember what a p-value is? I'll move this out of the way a little bit. Okay, that's good. That's awesome. So in biology, and I'm just going to reference this to biology because I don't want to counteract anybody, and sometimes your statistics change meaning a little bit, little quirky meanings when we get into a subject, okay? And in biology, your p-value is your acceptance of error, okay? Because what are we? Humans. And we make lots of errors, even if we follow very precise directions, doing everything over and over the same. We are not robots, okay? So we're going to accept error, make errors. And if we're working with living things, we may not be able to control everything, okay? So typically in biology, there are 2 percentages of errors that we typically go with. We're willing to accept 5% error, or we're willing to accept 1% error.
Which situation?
Yeah, that's a really good question.
Or is it just by like
So
each situation?
it is a little bit by each situation in the real world, okay? A lot of times it's dictated by the journal that you're doing the research and want to submit to, okay? So if I am a research scientist and I'm working on some research on the coronavirus, okay, and I want to publish in the Journal of American Medicine, or JAMA, I'm going to look at what their requirements are before I do my statistical test. I do not need to look at their requirements before I set up my experiment. Statistical tests are all done after the fact, right? So you're not having to change your experimental setup at all. But if I want to publish in Nature, they may have a different allowance, okay? For us, because right now that's all we care about, right? Let's be honest. For us and for in general, 5% is our rule. Okay, so we're willing to accept that 5% of our data could be wrong. All right, but we don't write that like this. How would we write it? We're going to do a statistical test. We're going to need to use this number in a calculator. So we're just going to need to write 0.05. That's it. That's your p-value. All right, so I'm not going to ever I'm going to take that back. There is one statistical test I'm going to make you do by hand, but it's not bad, okay? And it's not until way later. What you need to do now is plug this into a t-test calculator, okay? And there's all kinds of websites you can use for that. But you need a few more pieces of information. You need to know that this is an unpaired, I need to move my t-test. Unpaired. Yes. What do you think that means? Let's take a step back. What does it mean for something to be paired? They're together. Right. So this is saying that our two sets of data that we collected, they're not related to each other. They're not tied to each other in any way. So we would need to know that it's unpaired data. All right. And then this one's just really weird. We want to do a one-tailed test. I'm not even going to ask you what you think this means. I'm just going to tell you, okay? Because this one didn't make any sense to me for the longest time. One-tailed, so you have an option that your data is either one-tailed or two-tailed, okay? And if you think about the standard deviation bell bar, graph, the tails are those things. So a t-test does involve standard deviation. The tails would be both sides. If you're two tails, it's both sides. And the only time that you would be two tails is if you didn't know in your hypothesis, you couldn't pick which way it would be significant. All right? And sometimes that happens, right? We don't have enough prior knowledge. But in this case, we had enough prior knowledge, even probably before you started dropping and counting your drops, right? Without the soap, it's going to have more drops are going to be able to held together. So that's why we are a one-tailed test. Okay? So all you're going to do is plug your information into a statistical calculator for t-test, and you're going to get something that says a t-crit. And you're just going to compare. So our t-crit for this is our reference thing, okay, is 2.132. We did 5 trials. We are a one-tailed unpaired test. So this is our reference. So you're going to plug all your data into a t-test calculator, and it's going to give you a t-value that you're going to compare to this. Okay? If your number is higher than this critical value, then we reject the ho and we accept the ha. Accept the ho, yes. Okay, yeah, it's all kind of starting to come back, or maybe not, that's okay.
Is it always like you write out 2 hypotheses?
Uh-huh. It's the accepted. In biology, we are never right or wrong, okay? That's actually one serious fact that I would like for you to ingrain in your brain before you leave me in early May, late April, okay? We're never right or wrong. We only accept or reject, or our data supports or does not support. We can't ever prove anything frequently because we don't have enough data. You can't do enough data in the world. You can't do enough experiments to say for certain this is the way it is. Somebody's going to come behind you and figure out another way, and they're going to be like, no, you didn't prove nothing, right? So we just say we accept, we support, okay? Yes. So this is a reference number because we had 5 trials and we are one-tailed unpaired. So this you would get from like a chart, like a reference chart.
Like ever be able to find the t-crit?
No, t-crit is always going to be like from a table.
Okay, so it's going to be different.
Mm-hmm.
The standard deviation, that's like, you do that with every value.
Yes.
Every value.
Or use use a formula or a program to calculate that as well. Calculating standard deviation by hand is one of the most annoying things ever. It's really good to understand why it works, but it's really time consuming. You have to take you have to figure out the average.
Subtract the mean from every
Uh-huh.
and
then you
get
have-
the absolute value of every single one, and then you divide it by n minus 1.
Yep. You got it.
That's variance.
Yes.
Let's go.
Yeah, girl. So your plus and minus 1 is your standard deviation. So say your standard deviation is 1.01. So your plus would be, say your average was 56, okay, and your standard deviation is 1.01. So you would do plus 56 plus 1.01, and that is your top of your error bar.
Are you adding a subtract to the standard deviation?
That's it. Yep.
And then is the standard error the same thing as the 5%?
Yep. Yep.
So that's what you write in here. You write 5% or
Mhm.
5%.
Yep.
It's like what you guys put in the table for that.
Oh, yeah, just whatever you calculated for that. So it's, you have to calculate what your plus or minus. Uh-huh. Mm-hmm.
But standard error in the table is just 0.5.
Yep.
What is the last one? The plus or minus 2 SEM?
So standard error of the mean, okay? So that's what you have to calculate to get what your standard error is. So it's very similar to standard deviation, but it's another one that's starting to be like more popular among publications, because that's who you're checking to see what stats you're using, okay? And so you're just gonna do a calculation for that, like not by hand. Just plug that into a formula, like an online one.
If it's 2 SEM, isn't it just like 0.05 times 2?
No, so standard error of the mean is going to be a calculation that's based on your data. That is going to be, it's going to mean similar to your p-value of we're willing to accept that our data falls within this range, okay? If you did 100 more trials, right? We did 5 trials, right? That's not very many. But if you did 100 or even 1,000, your real average, your real mean would fall within that 2 standard errors. So that's what your plus and minus is going to be. Okay. Okay. Yes. Mhm. Yeah, perfect.
How many numbers of the decimal place?
Oh, in biology, we like 1 or 2 is fine.
Oh, so just
We don't care. Yeah, we don't care about significant digits.
okay.
Don't tell the chemistry teacher. All right, you had a question. You had a question.
Am I doing this right?
Yeah, that looks good. Perfect.
Like, you wanted us to.
Yep.
figure out all that,
Yep.
right? And then the hypothesis
Mhm.
was on the textbook.
Uh-huh.
It said that, like, what did it say?
I don't
The
remember either.
hypothesis, like, wasn't an if-then statement, but you wanted.
No, so you can, so that's just something new. Hypotheses don't have to be written in if-then statements. We teach you that up until high school or through high school typically, but it's not high school class, because it's easy, right? But if you start reading actual science journals, they are never written in an if-then statement. Okay, so this year, I don't care either way, but I would like for you guys to dabble in not writing them in an if-then statement, so that when you go to further science classes, your professors don't think you're an idiot. Okay? Yes, ma'am. Your claim is your answer to your question. So go back, and what was your research question at the very beginning?
How does the subtype bonds between different.
Okay, so your claim is going to answer that question. So in a way, it is similar to a hypothesis, but a claim is made after we've collected the data. So we have more knowledge and we have evidence that we can then use to support that claim. And it's not with explanation, it's just a statement, okay? And then your evidence will start to be your explanation, okay? Yes. Yes. So the bar graph, you're going to graph your average, Okay.
Both, both.
Uh-huh. So it's going to be a bar graph. You can graph your average. And then you're going to choose what do you want, what do you think is more significant? Do you want to do plus or minus 1 standard deviation, 2 standard deviations, or your standard error of the mean for your error bars? So that's going to be the little hat above and the little hat below, like I did up there.
Okay, so I'm just putting, like this I got for, this one got 20 for that one. I got
Mhm.
40. So I'm just putting
Okay,
that
so
in.
well, this is going to be a bar graph. So you're going to have water here and soap and water over here, and then these are going to be up there. Yep. All right, and let's, I'm totally fine with this notebook, but let's get you some graph paper.
Okay.
Okay. That's not what I need. Yeah, just glue it, tape it right on top. Here, you've got one too. When you do your graph, you can be more specific if you want. Yeah, there is. I don't know. I'm not gonna lie, I have not used a calculator like that for more than like just basic math since high school. Yeah. I would go online and find a standard deviation calculator. Actually, me personally, I love Excel and Google Sheets. I would probably put my data into that and tell that to calculate. Yes. 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 This is not math class. In biology, it's more important to understand what these numbers mean. Okay?
I always get caught up on the numbers.
Right.
And then
I
try to
gotcha.
explain everything else, and
Right.
it never works for me. So,
Yes. Yes. Uh-huh.
Oh, it's not like 0.05?
This is sample. We're not population. So population would be like all of the water droplets in the world.
Okay, and then
Okay.
I just have to plug in.
Yep. You just got to plug in. Yes, ma'am. What? I wasn't listening.
Everybody's p-value
Yes.
is the standard error.
Mhm. No. So standard error, you're going to calculate.
I was about to say, because I got a different answer. I'm
Yeah.
like,
Oh.
Yeah. Standard error, you're going to calculate, but it's based on the same theory of what your p-value is. Okay.
What decimal point do you want us to round?
1 or 2 is fine. In biology, we don't care. Yeah, I don't care. Biology becomes really nice once you take out all these quirky rules that we've drilled in your hands.
I think this is my TJ.
Uh-huh.
That's, what is the N?
The N is your number of trials, 5.
Oh.
I got 10.92. Yeah, it is.
And so everybody's data is going to be a little different because you've got different values, right? Around the same ballpark, but
Okay. So
Yes.
I got 0.4 for my standard deviation.
okay.
So now I add and subtract that from.
Yes.
Oh, this
And
is
then
my
your
standard.
2 standard deviations would be this times 2. So this would be 20.8 plus or minus.
So this is my standard.
Yes.
Okay.
Yes.
So I just put it-
Yes.
You just want me to
Yes.
write
Do you need
the-
some white out? You got it. It's either way's fine. I'm
you
sorry,
want me
touched
to
you.
just write both the positive and the negative just in here?
Yep. You can just do them like slashy, you know? Yep. Yes. Uh-huh.
The line that goes
Yes.
through there,
Uh-huh.
that's these two numbers, right?
Yep.
Plus.
Mhm.
Okay.
I really just forget math every single
You want those numbers labeled?
That's up to you. That's a graphing preference.
Wait, what did you ask?
He asked if your hat and your caps for your plus and your minus, if I wanted those numbers like labeled off to the side. That's a personal preference. If you made your graph legible enough, it shouldn't be necessary, but I also understand some students just like them labeled on there. That's fine. It's fine.
Ooh, I got a nice even number.
Nice. Makes you happy. All right. Okay, I need some water.
How would you set up the graph?
So it's going to be a bar graph, right? Because these are our two variables, and they're not continuous or related to each other.
So, do I have to put both of these names? I mean, not names,
Mhm.
names, and then all of these.
No, so you're going to do your error bars are just those numbers. Okay, is that the one that says yes with the plus or minus 2 standard error in the mean. So you're going to make your bar with this column, okay, and then you're going to draw a little hat on top to go up to there. Just see how I have a little hat on top and underneath. Okay, so you're going to draw a little line and then draw a little horizontal hat
Okay.
at 39.7 and one below at 34.7.
Thank you.
Yeah.
It's like, our value is 5%.
Uh-huh.
Does that mean we find the error at 95%?
Yes, we are confident that 95% of our data is awesome.
So wait, I can use that from like this website?
Yes, absolutely.
Wait, can you guys show me how to do this?
Yes, yes. Hold on, let me help her real quick. Okay. All right, so that's saying that you have your average, okay, and that your plus or minus would be the 7.2, and you can just stop right there, okay? So
Plus or minus?
plus or minus 7.2. Mm-hmm. Yep, you find that for the other one.
Okay, so
Yes, ma'am. Give me just a second. Uh-huh. Yep. Yep, that's it. All right, so question about whiteout. Are you capable of using whiteout tape?
Yeah.
Yeah? Okay. It is. And I ask that because I have 2 liquid backups. If you're not capable, this is what you get. I love whiteout. Whiteout is the best thing. When that stuff got invented, oh my gosh. It's a game changer. I don't know when it was actually invented, but I used it for the first time when I was in high school. So it was a long time ago, early 90s. No, you're fine. I'm just rambling about whiteout.
It's 0.05 for both of them, or do I have to get like calculate?
No, you need to calculate them. What you're calculating is the value of the 95% acceptance of your data being correct.
Okay,
Okay. I love your mask.
thank you. That's
also
perfect.
cool.
So I can use a standard error.
Yes, please. I do not calculate any of this by myself. The only calculation I do by hand is chi-square because it's easy and it's something we have to teach at every level.
I just feel like everyone says you have to do it by hand.
That's such a waste of time. Yeah, no, you're fine.
But for the standard
Yes.
deviation, you would just minus this
Uh-huh.
and then add that.
Yep.
Okay.
Yep.
You
And
want
then
both
for
values?
2, it would be doubled.
Exactly.
Mm-hmm. Yes.
I was just making sure I wasn't touching something.
No, I'll wipe it down. You're fine.
It's for numbers, okay. Error of the mean. Wait, so what numbers do we enter? Just the data?
Yes. No.
Data track?
How to what, baby? I'm sorry.
Title graph.
Title? Okay, so
Is
you're,
that like a versus? Or
So,
is that just
it can be, or it can be more descriptive, okay? So it can be the effect of soap on drops of water on a penny. That's fine. That's formulaic one, the effect of the IV on the DV. Or it can be more descriptive of number of drops of water on a penny with and without soap.
Okay.
Okay, so see how they both kind of say the same thing. Yes, folks?
sorry, so
No,
this is-
stop. Okay, first of all, I need to pause for a second because you're not the only one to do this.
Okay.
Guys, stop apologizing for questions, please. Okay? That's literally why we're here, for you to ask questions. And I want questions, okay? I think it's super cute. You're probably super in the habit of it, but It's not necessary, okay?
Alright, so, like, how much do I write up and down? Like, how do I add both ways or just one?
So you're gonna add both ways. So you're gonna use this number right here,
Oh, 'cause
okay?
both different ones
So
hit.
that's your, yeah.
So it really should
Mhm.
only go to, this was 33.6.
Yeah.
Yeah, me too.
Five,
It's on minidevtool.com.
Okay, I'm on the web.
33.6 plus
It's,
1.
it's a big box.
Yeah.
8,
Enter number
35.
There you go. Excellent.
Send y'all the link.
Uh-huh.
Do I write?
Yep.
What do I write next to the
You don't have to write anything.
Oh, so it just
Yeah,
gets it
because you're gonna write in your title with plus or minus 2 standard errors of the mean. If you add that to the title, then you don't have to add any values.
Right.
So you're just referencing with, right, with,
Mhm.
to plus or minus 2 standard error of the mean. There you go. Oh, Baxter, abbreviate that. SEM.
So
Next time I will.
Okay.
SEM is margin of error on the website.
Yes. Yes. You're winner. You guys are awesome.
What should I look up to find the last one?
We both had this.
Yeah, I looked up
Mm-hmm.
that, but I don't know.
No. T-test. You're just doing a basic t-test.
Okay.
So you need a t-test calculator. Your critical value is what you're going to compare your answer to decide if you're going to accept or reject that hoe. Yes.
I have the standard error of the mean.
Awesome.
Now I multiply by 2 and subtract it from the mean.
Yes.
Okay.
Mm-hmm. Unpaired one tail.
And the two SEM.
Uh-huh.
Make a claim.
Yes. Okay, so your t-test value that you calculate, or that the internet calculates for you, you compare to your t-crit, okay? If your t-test value is higher than your reference value, your t-crit, then you reject the hoe. Sorry. You reject the hoe. You want your number to be higher. And like a lot of times it is. Most of the time in biology it is. So if we're rejecting the hoe, then you say that there is a statistical difference. So we're rejecting the hoe, which means we accept the ha. If your t-test value is less than your critical, then we do the opposite. We accept the hoe, right?
Say accept or do you say rejecting?
Either one. I don't care. For biology, we don't care.
Okay.
I know. See, it's another one of those for biology, we don't care. Yeah, so do the way that you're comfortable with. So that means that there would be, so your data could look like there's a difference, right, in your raw values or even your averages, but when we do this calculation, it's really not statistically significant. It could be random chance, which is very likely with only 5 trials too, right? So that's one of the reasons why we only do 5 trials.
So like this.
Uh-huh.
I wrote that.
Perfect. Yes, that looks great. Perfect. Yes.
When I scan my papers, they're going to be really.
Oh, no. I love it. It's fantastic.
Okay, so
We're not perfectionists. We're not. We're not.
for my conclusion, making a claim, so I
Yes.
can just write
So your claim is a one-liner that answers your research question back here.
oh, how does soap affect the hydrogen molecule? It's separates them.
Okay.
So
So separates, breaks, okay?
It
But
breaks.
see how it's not a Y. It's just
Explodes.
a one sentence. Soap separates the hydrogen bonds of the water molecules. And then the next part is going to take you into your explanation. Uh-huh.
I would get to the 95%
Mhm.
level.
Yes,
and
ma'am.
These two numbers.
Yes, ma'am.
Okay.
Well, this first one is your average.
Yes,
Should
this
be, yes.
is the average, but
Yes.
these two
Yes.
would be
Uh-huh.
the 1% and the 2. Or
Uh-huh.
1 and 2.
Yep.
Okay, I need help.
Okay.
How do I make my graph in t-test?
Okay. Well, so your t-test, you're going to find a t-test calculator.
Okay.
And then you plug your data in There you go. She sent one in the group chat.
Oh,
Oh.
okay. T-test.
Okay, hold on just a second.
So are we making 2 t-tests?
No, we're just doing one t-test.
Are you entering all the data for like both thingies?
It'll probably just ask you to do your mean and I think your standard deviation, and then you have to tell it that it's unpaired and one-tailed.
Wait, but there are 2 means.
Right.
So
Yeah.
both
Yes. 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 Because a t-test is comparing your data. It's a categorical comparison. Okay. All right, I'm gonna come back. All right, so what do we do with this value?
I
All right,
got the T-score.
awesome. Is this number higher or lower than this number?
That's higher.
It's
so
higher.
That we reject.
Yes.
Which was correct anyway, based on just the words.
Right.
So that just proved it.
Yes, it supports this. It says it's statistical difference.
So it says
Mhm.
with explanation of what it means. So I would just put.
That is what it means. Like it's in words what we just said.
So I
That
don't have
you're.
to write anything. That just proves it.
Well, but I want you to write it in words so that I know that you understand.
Okay, so
yes.
for the explanation of what it means, I'm gonna put that.
That we reject.
We reject this one.
Uh-huh. So that means there is a statistical difference. Yes.
So
Uh-huh.
what do I enter?
Okay. So it looks like it does want you to enter your raw data in this one, and that's fine. See, look, it says you right up here. Yep. And then, oh no, enter your mean, your standard. Yeah. See, it wants you to tell it what you want it to do. See, there you go. There you go. All right, baby.
For my graph,
Uh-huh.
it says I can make a bar graph.
Yep.
When it says with and without cells within 95% confidence, I have that here.
Yes.
But what does that mean?
So that's the little hats. See the little hat above and below?
Okay, so I draw the
Yeah, you draw a little hat.
up until these.
Uh-huh. So this will be your up hat,
Okay.
and this is your down
And
hat.
that's just like a line with 2 things on it?
Yes.
Okay.
Yes. Huh? N is your number trials.
Or am I not supposed to
I do. No, I can give you a ruler. I just have to sanitize it, which means I hide them. That's all. And no, it's fine. I'm gonna need you to move your desk for a second. My rulers are hidden behind you. I'm sorry. They're not. I'm gonna have to move them. There you go. And you can just leave it on your desk when you're done. Yep. Oh, you're fine. I know it's so weird. I have to carry your own ruler. Well, you have to tell it one tail. And if you can't, just roll with it. It's not going to be that different.
Do you mind if I did my?
It's fine. It's fine.
Do you
Huh?
mind if I did my T table like after my?
Oh no, that's fine. As long as you have it, I don't care what order it's in. As long as you've got it. You're fine. I talk to myself all the time. It's bizarre. All right, we're in here. All right, guys, we got 6 minutes left in class. We're not going to panic.
I have one more question.
Okay? You can have as many questions as you want. And this lab is not due until next Friday. Yeah, word. Next Friday.
You're teaching us how to scan.
Yes.
Okay, that's what I was gonna ask.
I'll do a little video too so that you don't have to so yeah. Oh, that was your question? No, you had another question.
Oh, no, I was just trying to figure out the last part of the
Okay.
I think I've got everything else.
Okay. Your mom had said, sorry, I have a crick in my neck. Your mom had said in her survey that you guys sometimes have bad Wi-Fi access. If at any time you think accessing the reading questions has become, I can give them to you printed. Okay, because I can give them to you printed out.
Yeah,
Okay.
it's just bad with like.
Yeah.
But I can do that one.
Okay, just checking. All right.
I'm gonna try medic calculator.
All right, online kiddos, if you're ever checking out this video, I'm stopping it now. I'm going to post a video on how to upload something. Somehow I'm going to do that and get that up this weekend. So, all right.